So, in the following videos, they're not necessarily specific to section 6.6. They kind of are, but they're more for our MYP quarter 2 unit project. So on the unit project, we have some polynomials that we need you to factor. And then we have some other things you're going to go backwards. We'll give you the factors, and you have to remultiply, and we'll do a couple of the other ones. I have those examples in the other videos. So to help you do some of the factoring, I'm going to make a couple of videos of the stuff that you're going to kind of see on that sheet. And I thought I'd do one problem per video, and it's going to take a little bit of time, and I'll go slow. So yeah, okay, fine, let's get started. There's enough of me talking about it, let's just do it. So, first of all, we're going to talk about finding the zeros of polynomial functions that have exponents that are larger than 2. And the reason why I said exponents larger than 2 is because those are quadratic, and we already found the zeros of that. We spent all of chapter 5 doing that. And we're going to use that, we're going to go back to that. So, as we do some of the stuff, because we're going to end up with some quadratics. Okay. Speaking of quadratics, what did we know about finding zeros? Well, there were 5 things that we did. Not all of them are going to apply, but some of them will. Excuse me. One thing that we did was we graphed the quadratic, and if the parabola, the graph of the quadratic function is called a parabola, makes a U-shape. If that crossed the x-axis, we found out where those 2 places were, or sometimes just the vertex touches. And so we found out where that was too. Sometimes it didn't intersect the x-axis, so we had to use a different method. But graphing sometimes works. So we're going to do some graphing here. Maybe graphing will help out with this. We also factored, and which of course, because you can kind of tell by the directions for this, factoring is going to be important. We're going to try to find factors. And then we also used square roots when that was a possibility, when that would have worked. And if it didn't work, we made square roots work by completing the square. And of course, our old friend, the quadratic formula, that works all the time. And that's how we find the zeros of quadratic functions. Well, polynomial functions of higher order, that means higher exponents, higher degree. We can use those same type of ideas to find the zeros of those. So let me show you what I'm talking about by just doing this example, all right? So I have yet to figure out how to record by switching over to Desmos, so I'm going to pull out another iPad here, and I've got Desmos open up. And I know, I'll try to move this to where there you go. Just saw the reflection on the screen. Anyway, okay, so what I did was I took this function, which I call p of x, p for polynomial. I know usually we call f of x, but don't worry about that. And I just graphed it. So let's see what this graph looks like. I already put it in here. All right, that's cool. Now, one thing about, just a little side thing, one thing about these functions that are to the 4th power, they are going to look like W's or M's if I flip it up, if I do a vertical reflection, okay? But this one, there's no negative in front of the x to the 4th power, so it's going to look like this W shape. Now, I know you're probably looking at it going, that doesn't look like a W, but it kind of does. It comes down, goes up, comes down. It only comes down a little bit though, and then it goes back up. Keep that in mind. That's going to be very important, okay? So remember that I said that. All right, what do we know so far? Well, this does not cross the x-axis, but it does come down here, and it actually touches the x-axis, touches it right there. So I think, oops, move that so you can see it. There you go. I think that one of the zeros from the graph is going to be x equals -2. All right. So we're going to try, make sure everything's lined up here. We think I can use x equals -2. We think that's one of the zeros. At least that's what it seems like from Desmos. So how do I know if this is going to work? If this is the case, that means that one of the factors of p of x is going to be x plus 2. Because if x plus 2 equals 0, then x equals negative 2. I'm just working backwards from solving it. So let's use synthetic division to find out if this is going to work. So I'm going to use negative 2, and I got 1, 2, negative 2, 0, don't forget the 0x, 8. 1, 2, negative 2, 0, and 8. So I got 1 plus 0 equals 1, negative 2 times 1 is negative 2, 2 plus negative 2 is 0. 2 times 0 is 0, negative 2 plus 0 is negative 2. Negative 2 times negative 2 is positive 4. 0 plus 4 is 4, and negative 2 times 4 is negative 8, giving me a remainder of 0. And as you just learned in the last section, that means that it is a factor. So this is my factored form so far. My p of x in factored form is going to be x plus 2, because negative 2 plus 2 equals 0, times, this is my constant, x squared, x cubed. So I've got 1x cubed plus 0x squared, subtract 2x plus 4. All right, cool. So I've been able to factor it, and I've gone from fourth power to third power. I've knocked it down a whole degree. That's great. What's not great is that I don't know how to factor x cubed subtract 2x plus 4. I could try it by grouping, but that's not going to work in this case. So let's go back to Desmos. Let's do the same thing I just did. Here's my x cubed subtract 2x plus 4. Now, cubic functions make this S shape. And we already talked about quadratic functions make a U shape. All of that is stuff that we are going to, in Algebra 2, we kind of hint at and we kind of introduce you to it, but you're going to totally explore that in in pre-calc next year. All right, but anyway, I'm getting ahead of myself. Does it have a 0? Well, actually it does. This has a 0, another 0 at negative 2. Now that's not the same 0, because I've already factored out the x plus 2. That's a different 0. What that means is I get the same thing twice. I get 2 zeros at the same place. That's called a multiplicity. So I'm going to try negative 2 again. This time I'm going to do 1, 0x squared, negative 2, 4. 1, 0, negative 2, 4. So here's my 0, 1 plus 0 is 1, negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. 4 plus negative 2 is 2. Negative 2 times 2 is negative 4, and just like last time, I get no remainder. So now, my factored form is x plus 2, that one right there, times another x plus 2, times x squared, subtract 2x, plus 2. X squared, subtract 2x plus 2. So now, look at what I've done. I've gone from a quartic, power of 4, to a cubic, power of 3, to now a quadratic, power of 2. I keep chipping away at it. Now, you know all about quadratics. I can try to factor this. What two numbers multiply to give positive 2 that add to give negative 2? Well, they both have to be negative. Negative 1 times negative 2 would add up to negative 3. That's it. 2's prime. So if I'm going to get it, I don't have any other factors. So what does that mean? That means that in order for me to find the zeros here, this now is completely factored. Okay, currently this is completely factored. So if I was doing this for the prep work for the project, this would be my factored form that I would have. But the question says, well, what are the zeros? All right, so I know x plus 2 equals 0. One of my zeros is negative 2. So one of my zeros is negative 2. I also have another 0 at negative 2. These are the same like I said it a moment ago, I'll write it this time. This is called a multiplicity. It just means you got the same thing twice, or more than twice. In this case, twice, but sometimes you can get the same thing over and over again. What about this one? All right, so now I'm going to find the zeros using the quadratic formula. So I've got 0 equals x to the second power, subtract 2x plus 2. My discriminant, b squared minus 4ac. This is going to be negative 2 squared, subtract 4 times 1 times 2. This is 4 subtract 8, which equals negative 4. And remember what we heard about when the discriminant is negative? That means you're going to get 2 zeros, but they will not be real. They'll have an imaginary component. Let's go back to Desmos for a moment and talk about this. This is y to the second minus 2x plus 2. And now look at the graph. The graph does not intersect the x-axis. So that means, that means that we are going to get zeros that have imaginary components, or an easier way is just to say they're not going to be real. Although you know how I feel about real and imaginary. So keep working the quadratic formula. And I'm not teaching the quadratic formula now. If this doesn't make sense, go back and watch the 5-6 videos. All right, I'm using the quadratic formula as part of a bigger problem. So I get negative b, which is the opposite of negative 2, plus or minus the square root of negative 4 divided by 2 times 1. This is 2 plus or minus 2i divided by 2, which means I get 1 plus I, and my other 0 is 1 subtract I, because the 2's are going to reduce. So here are my zeros. X equals negative 2, x equals negative 2 again, x equals 1 plus I, and x equals 1 subtract I. The last thing is, how many zeros did I get? 1, 2, 3, 4. This gives me 4 zeros. All right, we'll see you in the next video.